The first question is about IQs. It follows a normal distribution with a mean of 100 and a standard deviation of 15. They want us to fill in the z-scores of 3 above and 3 below the mean. So I make a line going straight down for a z-score of 0, and that corresponds to the mean of 100. Then I have a z-score of 1. I'm adding 15. Again, we have a standard deviation of 15, so 15 as I move up to each z-score. And as I go down, I will also do the exact same thing. I'm going to subtract 15. And then they want you to find out what is the z-score. What is the z-score with a data point of 120? So I'm going to take 120 and subtract the average. Make sure to press enter and then divide by the standard deviation. So I'm going to round to the nearest hundredth. So this is approximately 1.33. 1.33. Now, what is not on this particular review that is on your test is you are asked, would we consider this data point or this IQ score of 120 to be statistically significant or insignificant, and explain. To your partner, you have 10 seconds, go. Anything in the range of -2 to +2, anything in this range is considered to be statistically insignificant. Anything above 2 or below 2 is considered to be statistically significant. Now, what is your explanation? If your answer is statistically insignificant, it's because it falls in the middle 95th percentile, and it's between -2 to +2 z-scores from the mean. If your answer would be statistically significant, it falls outside of the middle 95th percentile, and it's above 2 z-scores from the mean, or it's below 2 z-scores from the mean. That would be your explanation. Okay, going down to the next one. I know that the wording in the test is a little more difficult, so I'm going to cross out the word higher than, and I'm going to say at least. Determine the percentage of people with an IQ score of at least 120. So you look up here and you go, is 120 landing on one of the columns? If it's not, here's how you show work. Okay, so 120 would be approximately right here. And at least means this portion or above. 120 would be the smaller of the numbers. Your average is 100, standard deviation is 15. What do we replace with the large number? It would be 9999. Okay, let's round. Let's get a percentage and round it to the nearest tenth of a percent. I have approximately 9.1%. Approximately 9.1%. Okay, the next one, find the percentage of people who have IQs between 95 and 100. Is 95 to 100 landing on the lines? It is. So I don't have to do a normal CDF. Remember, this is 34 and 34, 13.5 and 13.5. This is 2.35 and 2.35. This is 0.15 and 0.15. So between 85 and 100 would be 34%. Okay, going down to the last one. Approximately 95% of all people have an IQ between, so remember 95 is between -2 and +2 z-scores. So what numbers match up with those? It would be between 70 to 130. Okay, going on to the next one. Crunchy Critters produces bags of chips. That doesn't sound so good. The mean weight of the chips is 16 ounces. The standard deviation is 0.3. We're going to fill in this 3 above and 3 below the mean. So here's your 0, 1, 2, and 3. -1, -2, -3. And I'm going to add by 0.3 to the mean of 16. So 16.3, 16.6, 16.9, going down. You're going to make sure I don't make any mistakes here. 15.7, 15.4, 15.1. All right, find the z-score. Find the z-score corresponding to 16.5. So 16.5 is right here, just so we keep that in mind. And to find the z-score, I'm going to take the data point, subtract the mean, divided by the standard deviation. And I'm going to round it to the nearest hundredth, and I will definitely make sure that they're directions so you know what to round to. And I came up with this when I subtracted the data point, subtract the mean, get an answer, and divide by standard deviation. So I'm going to say 1.67 approximately. Now, turn to your partner. Is that considered to be statistically significant or insignificant, and why? Go, 15 seconds. It is considered to be statistically insignificant. Why? Because it lands in the middle, 95th percentile, and it is between -2 to +2 standard deviations from the mean. All right, now let's go to the next one. It says, determine the percentage of bags that are at most 16.5 ounces. Well, 16.5 we can see does not land on one of the columns, so I'm going to need to use the normal CDF, and 16.5 is here. When I see the word at most, it means everything up to that point but not exceeding it. This is the largest number, 16.5. And my average for this problem is 16, and standard deviation is 0.3. I don't know the smallest, so it's -999. Let's find a percentage and round it to the nearest tenth of a percent. Approximately 95.2%. Approximately 95.2%. Okay, the next part says, find the percentage of bags that weigh between 15 to 15.5 ounces. Well, 15 is not on one of the columns, and 15.5 is not on one of the columns, which means I get to use the normal CDF again. 15 is the small, 15.5 is the large. Again, we know the mean and the standard deviation. And the answer would be approximately 4.7%. Approximately 4.7%. Now, the last part says approximately what percent of all people have IQs that are in the middle 67th percentile. So 68th percentile. 68th is between -1 to +1 standard deviations from the mean. So that would be 15.8 to 16.3. 15.7 to 16.3. Okay, let's pretend that this particular problem says out of 100 people, out of 100 bags, I'm going back to the last problem here, out of 100 bags of chips, what percent or how many bags can we expect to be at least 16.1 ounces? At least 16.1 ounces. So at least means, let's find 16.1 up above. 16.1 is approximately right here. At least means this point or above. Since 16.1 does not lie on one of the columns, I'm going to first rely on normal CDF to come up with the percentage. 16.1 is the smallest of the numbers. And the largest of the numbers is 999. Okay, let's figure out the percentage first. I have approximately 36.9%. Approximately 36.9% of the bags would be at least 16.1 ounces. So if there's 100 bags, how do I figure out how many we can expect to be at least 16.1 ounces? We turn this percentage back into a decimal, take it times 100, and we can see 36.9 bags. So if we rounded, we could say we could expect 37 bags out of 100 to weigh at least 16.1 ounces. Okay, so for this next problem, on a certain website, the ages of employees fit a normal distribution where the mean is 32 and the standard deviation is 4. Let's first fill out the chart. So this is 32, 1, 2, and 3, and going down -1, -2, -3. So add 4, add 4, add 4. Subtract 4, going the opposite direction. And I'm going to take time to write the percentages in right away. I would advise you to do the exact same thing when you get to your exam. Okay, so this problem is a little bit different. This problem gives us 5 different options, and they want us to come up with the percentage that falls into the normal distribution curve up above. So older than 32. 32 is right here. If you're older, you're to the right. So if you add up everything to the right, well, it's half the curve. Half the curve is what percentage? That was an easier one, but you could add up these 4 and you'd still come up with 50. Younger than 28. So I find 28 and I add up the 3 to the left. When you add up the 3 to the left, it comes up to 16%. Between 28 to 36. Here's 28, here's 36. 34 and 34 is 68. Jesus, head up. Younger than 40. Well, here's 40. If I had add up everything to the left, it would come up to 97.5%. Between 32 to 40. Here's 32, here's 40. Adding those up, you come up with, can you guys add those up for me? What percentage do you have exactly? What is it? 47.5%.